Good morning. To prove that the vector space generated by the vectors 2, 4, 6, 4, 4, 10 and 4, 8, 12 is equal to the vector space generated by the vectors 1, 2, 3 and 2, 2, 5. So if I suppose this vector space to be as V and this vector space to be as W, then I need to prove that both the vector spaces are equal. That is, V is equal to W. And when the vector spaces are equal, if they are having the same bases, right? So let's check. So first let V be the vector space generated by the vectors 2, 4, 6, 4, 4, 10 and 4, 8, 12. So let's write these vectors in a matrix form. So it is 2, 4, 6, 4, 4, 10 and 4, 8, 12. First we need to change this matrix into the row echelon form, right, to get the basis for the vector space. Alright, so I need to make this element 1. For that, just dividing the row 1 with 2, right? So row 1 is divided by 2, or you can also say that the elements of the row 1 is multiplied with, yes, 1 over 2. Writing the other rows as it is. To make this our leading element, we need to make the other elements of the first column to be 0. For that, row 2 is changed and adding its elements to the row 1, but row 1 should be first multiplied with negative 4, right? So writing the row operation for the row 2 is to be changed and adding its elements to the row 1, but row 1 should be first multiplied with negative 4. So writing the first row as it is, because we are going to change the second row. 1 is multiplied with minus 4, we get minus 4, and adding this to 4 we get 0. 2 is multiplied with minus 4, we get minus 8, and adding this to 4 we get minus 4. 3 is multiplied with minus 4, we get minus 12, and adding this to 10 we get minus 2. Similarly, also we need to change the row third and adding its elements to the row 1, but row 1 should be first multiplied with again minus 4, so that I can get 0 over here. Writing the row operation. Writing the row operation for the row third. Row 3 is changed and adding its element to the row 1, but row 1 should be first multiplied with minus 4. 1 is multiplied with minus 4, we get minus 4, and adding this to 4 we get 0. 2 is multiplied with minus 4, we get minus 8, and adding this to 8 we get 0. 3 is multiplied with minus 4, we get minus 12, and adding this element to the 12 we get 0. So this becomes our leading entry, right? Now to make this as 1 for the second row, and for that we just need to multiply the row 2 with minus 1 over 4, right? So writing the row operation for the row 2 again. Row 2 is multiplied with minus 1 over 4. So writing the first row as it is, writing the third row as it is, and now writing the elements for the row 2. 0 is multiplied with minus 1 by 4, we get 0. Minus 4 is multiplied with minus 1 by 4, we get 1. Minus 2 is multiplied with minus 1 by 4, we get 1 over 2, right? To make this our leading element for the second row, we need to make this as 0 now. For that, row 1 is needed to be changed and adding its elements to the row 2, but row 2 should be first multiplied with negative 2 so that I can get 0 over here, right? Because I need to change the row 1, so the row operation is row 1 is needed to be changed and adding its elements to the row 2, but row 2 should be first multiplied with minus 2. So writing the second row as it is and third row as it is, and now writing the elements for the first row. 0 is multiplied with minus 2, we get 0, and adding this to 1 we get 1, no change. 1 is multiplied with minus 2, we get minus 2, and adding this to 2 we get 0. 1 half is multiplied with minus 2, we get minus 1, and adding this to 3 we get 2, right? So this also becomes our leading element now. So we have got our leading elements as 1 in the first row and also in the second row, right? That is in the non-zero rows. So this is now finally our row echelon form. And now writing the basis for V, that is from the first row we get 1, 0, 2 and from the second row we get 0, 1 and 1/2. So writing the basis as B1, that is the basis for V, that is from the first row we get 1, 0, 2 and from the second row 0, 1, 1/2. So now let's find out the basis for the another vector space, that is, let's say W, right? And let's check whether the bases of W are same as that of V or not, right? So again, let W be the vector space generated by the vectors 1, 2, 3 and 2, 2, 5. And let's write these vectors in the matrix form named as B, right? So it is 1, 2, 3 and 2, 2, 5. Already we are having 1 over here. To make this to be the leading element, we need to make this 2 to be as 0. For that, what we have to do is row 2 should be changed and adding its elements to the row 1, but row 1 should be first multiplied with, yes, -2, so that I can get 0 over here, right? Okay, so because I need to change the row 2, I am writing the first row as it is, that is 1, 2 and 3, and writing the row operation for the second row. Second row is to be changed by adding its elements to the row 1, but row 1 should be first multiplied with -2. So 1 is multiplied with -2, we get -2, and adding this to 2 we get 0. 4 we get -2. 3 is multiplied with -2, we get -6, and adding this to 5 we get -1, right? So we get our leading element as 1 for the first row. Now to get the leading element for the second row as 1. How to make this as 1? Just dividing the row 2 by -2, right? So the row operation is the elements of the row 2 are multiplied with, or you can also say that the elements of the row 2 are multiplied with -1/2. So writing the first row as it is, and elements of the row 2 are multiplied with -1/2, so that is 0, and here we get 1, and this is 2, 1 over 2. So 0 multiplied with -1/2 we get 0, -2 multiplied with -1/2 we get 1, -1 multiplied with -1/2 we get 1/2. To make this our leading element, we need to make this to be as 0 now. So row 1 needs to be changed and adding its elements to the row 2, but row 2 should be first multiplied with, yes, -2. Writing the first row as it is, writing the second row as it is, writing the row operation for the first row, because we are going to change the first row. This means we are going to change the first row. First row needed to be changed and adding its elements to the row 2, but row 2 should be first multiplied with -2. Okay. 0 multiplied with -2 we get 0, and adding this to 1 we get 1, no change. 1 is multiplied with -2 we get -2, and adding this to 2 we get 0. 1/2 is multiplied with -2 we get -1, and adding this to 3 we get 2. So now we get another leading element for the second row, and also there is already a leading element for the first row. So this is now your row echelon form. And now writing the basis for W, that is from the first row we get 1, 0, 2. And from the second row we get 0, 1 and 1/2. Let's check that these bases are same as that of B1 or not. Yes. The bases for V are 1, 0, 2 and 0, 1, 1/2. And the bases for W are 1, 0, 2 and 0, 1, 1/2. That is same. So since B1, that is the basis for V, is equal to the basis for W, that is B2. So therefore, V and W have same basis. Thus, both the vector spaces are equal, right? Hence the result. Thank you.